Thank you very much. First, I'll thank you for inviting me to speak today to you around artificial intelligence, responsible AI, and my area of passion, and that is the intersection of artificial intelligence and health. My name is Geralyn Miller, and I am the program lead at Microsoft in the Philanthropies Organization for the AI for Health initiative. I'm going to walk you through a few things today. I'm going to start with walking you through at Microsoft how we view responsible AI, what it means in the framework that we put in place when we engage with nonprofits and with research and with academic entities to guide and govern the projects that we take on. I'm then going to flip gears a little bit and share with you, let you peek into a little bit about how our company views the concept of responsible AI and how we have put mechanisms and structures or frameworks in place to guide the rich set of work that happens all over the world at different Microsoft places. And then I'm going to switch gears and talk about my area of passion, and that's the health projects. I'll share with you a few of these, what they look like, and then I'll annotate with particular cases where all of the things that we're going to talk to about responsible AI came into bear on these projects. So with that, I am going to go off of video. I am coming to you from a very gray and rainy Seattle, Washington, where we are still in stage 5 due to COVID. So we are, which means we are not in the office. So I'm coming to you from my home office. So to save bandwidth, I'm going to shut off my camera as I start the presentation. All right. So after decades of slow progress, there's been a lot of advances in artificial intelligence. And when you step back and look at it, these are really opening up a door to new types of solutions that have the potential to transform every field of human endeavor. This potential for artificial intelligence is so profound that there are people who claim we are in the early stages of a 4th industrial revolution. A recent report by Accenture, estimates that artificial intelligence and these types of projects could double economic growth and increase productivity across the world by 40% by 2035. So clearly there's a ton of opportunity around artificial intelligence. But just like the steam engine that drove the first industrial revolution and the electric power that made mass production in factories possible during the second industrial revolution and digital computing that sparked the third industrial revolution, change of this type of magnitude always comes with disruption and, more importantly, uncertainty. So I want to talk a little bit about some of the advances that make AI real. There are 2 fundamental trends that are really fueling this AI revolution and this steep ramp towards adoption of AI. The first is the vast amounts of data, right? We see availability of unprecedented amounts of data, coupled with drops in the cost to store and retrieve that data, coupled with the availability of storing data in clouds. These large quantities of structured and unstructured data about human activities and content have become available as we digitize and shift to the web, all kinds of activities around commerce and retail, science, communication, governance, education, and even art and entertainment. I've seen some stats that said the world's data is doubling every 2 years, and that we've created more data in the past few years than in all of human history leading up to this time. I can speak from firsthand experience for the work that my team is doing. We recently put some of the International Genome Consortium data on Azure. It was close to a petabyte of data and literally took months to move the data and load it into our Toronto Azure Cloud Data Center. The second advance that is really making AI real is huge computational power. And I think you're all aware of that. But, this widespread availability of tremendous compute power available, at your fingertips with the swipe of a credit card in the public cloud to analyze this data. The heart has really been at the cloud of delivering these huge increases in compute capabilities. When I step back and look at this past 18 months or almost going on 2 years now of COVID-19, one of the things that comes to mind for me in this area of huge computational power is the work that was done in the US with the COVID-19 HPC consortium. This was a public-private consortium pulling compute resources, not only from public clouds, but from the government-sponsored Department of Energy Lab, or DOE labs, and also the National Science Foundation funded labs. Together, the computational power brought to this high performance computing consortium that was focused on solving problems with COVID-19 was over 60 petaflops. So it's a ton of compute. So it's compute and data that are causing all this to happen. Okay, so artificial intelligence has incredible promise. We're already beginning to see what's possible when we take human-centered approaches to AI. We have advances in spaces where information previously beyond human observation, beyond the ability of humans to see, can be gleaned from just the data itself. In the UK, Microsoft Research, for example, is working with oncologists on a project called InnerEye, where we use AI to mark the boundaries between healthy tissues and tumors in CT scans for the purposes of targeting radiation therapy. Today, this annotation is a really time-consuming job that is done by hand, pixel by pixel, and hundreds of layers of scanned. What InnerEye accomplishes in seconds would literally take, days, perhaps even, hours or, days for an individual to do this. In the US, we're also working with scientists and epidemiologists on something called Project Premonition, where we're developing new ways using AI to detect dangerous pathogens like Zika and Ebola in the environment for the purpose of protecting people from transmission before deadly outbreaks can begin. This is done by collecting and analyzing using artificial intelligence data from the environment, including data collected directly from the blood that is inside mosquitoes. In our FarmBeats project, we're using the power of the cloud machine learning to improve agricultural yield, lower costs, and reduce the environmental impact of farming. So FarmBeats is also about increasing food production, but also minimizing the footprint of that from a sustainability standpoint. And with this one, we're collecting just vast amounts of data. So, at Microsoft, we believe that these are just hints of what is possible and the unprecedented opportunity that artificial intelligence offers. But artificial intelligence, as you know, with the opportunity comes great responsibility and a lot of challenges. I listed, some topics today that are all, you see often in the news that are, rich areas for debates, right? A lot about deep fakes right now, facial recognition, a lot happening in the regulatory space. These challenges and questions that are raised through the use of AI, should be guiding for all of us a thoughtful, responsible approach to how we look at AI and a set of actions that we can all take to advance the promise of AI in ways that don't cause harm to people. So at Microsoft, we believe our philosophy is that if you're going to truly harness the potential of AI, you need to take a human-centered approach, right? So we see that technology is not a substitute for human insight and judgment, but that technological tools can help us understand the world more clearly and help us make better decisions. So our goal isn't to replace people with machines, but rather to supplement human capabilities and eliminate these routine tasks. Like, for example, I talked about the CT scan annotation so that people can focus on work that is more strategic. In a lot of ways, this vision for artificial intelligence is really kind of mapped to the way that as a company, we've always looked at technology. When Bill Gates and Paul Allen founded Microsoft over 40 years ago, their aim was to bring the benefits of computing, largely compute that was locked up in mainframe, to everybody, right? And today at Microsoft, we're committed to doing the same for AI. We're deploying AI systems with the goal of making them available to all. And we aspire to build systems that reflect timeless values so that AI will be trusted by all. I bet. But as computers behave more like humans, how are they going to impact real people? It's important to think about this impact that computers and artificial intelligence are going to have on people and the ethics that should underpin AI. Every ethical question that has ever been faced by humanity could become an ethical question that we need to think about in relation to computing, especially as we see AI becoming more democratized and in the hands of more people. So published in 2018, Microsoft President Brad Smith and the Microsoft research lead Harry Shum had a book called The Future Computed. And in this book, they suggest that one of the fundamental questions of the era of artificial intelligence is not only what computers can do, but what computers should do. And I really want to pause and focus on that and think about this. And I think that when you step back and you look at why we talk about responsible AI and why we talk about ethical frameworks for the use of technology, it's really ties back to this question. Yeah, we know computers can do this now, but what is the right thing to do here? So Microsoft is just one of many, 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 many entities in industry, government, and civil society that are exploring these questions. And that's an important point. This is a conversation that everyone in society has to come together to answer. You can't leave this to technology companies or academic research entities to answer the question. We all have to come together to address this issue together. So I'm going to walk you through what at Microsoft is a framework for how we look at artificial intelligence. This set of principles was first launched back in 2018 in that book, The Future Computed. And this framework still guides what we do today as a company in terms of the products that we bring to light, how we manage our own data, and also how we guide programs like the ones that I run that are specifically looking at the intersection of artificial intelligence and technology. So let me give you just a high level of these, and then I'll do a quick drill on each, and then we'll talk about the application of these principles. So there are 6 core principles that we believe should guide the work around AI. There's 4 core principles of fairness, reliability, and safety, privacy and security, and also inclusiveness. There's 2 fundamental principles that are foundational layers. Think of this like a layer cake, and these underpin all of the other 4. And those are transparency and accountability. So I'll give you a quick drill into how we view each of these in terms of its application to the work we do. So the first principle, and I think this goes without saying, is fairness, right? For AI, this means AI systems should treat everyone fairly and avoid affecting similar groups of people in different ways. We've all seen in the news examples when AI systems don't do this, when they provide guidance on medical treatment or loan applications or college applications, and they are biased in some way, right? I think we're all here today because we understand fundamentally that bias can be a problem in AI, right? Each of us as humans, we carry around these inherited biases. Those biases affect our decisions and actions, and our decisions and actions are recorded on data. When I stepped into the conversation, there was a great chat about data stewardship, right? And one of the things we need to think about too is how data is collected, and is there inherently bias in the data that we're using to train the models? And stepping back and thinking about humans with biases, when we structure teams that are creating these models and doing the research using artificial intelligence, it's really important to think about the demographic of the team. My group at Microsoft is comprised of about 40 data scientists, and we take a hard look at the makeup of our team. So we want to see a rich diversity in terms of race and ethnicity, gender, age, background, and also rich diversity in the areas of expertise that people bring to the problem. And I think this is often understated and forgotten. Sometimes we think about equity and inclusion and bias and things, and we focus on one set of demographics, and we forget that domain expertise is really an area where you need to think hard about where biases can creep in. So, we have people with computer science background, deep learning background, computer vision backgrounds, NLP backgrounds, but we also have people who come from very different industries. I have a computational biologist that is on my team, a biostatistician, an MD, but we also have people with backgrounds in linguistics, in economics, in cryptography. So getting that experience across the board is, I think, really important when you're sitting and looking at the makeup of teams. Fairness is one of the largest fields of AI ethics and research, and it's not a solved challenge. I just want to point that out, right? But the first thing is that, we look at this as you have to acknowledge that there are problems with fairness, right? And be honest and transparent about that before you can actually start to solve the problem. So that's the first principle, fairness. The second principle is really reliability and safety. If you're going to build trust with these systems, it's important that these systems operate reliably, safely, and consistently, not only under normal circumstances, but in unexpected conditions. I think you all saw an example in the news recently where there was a traffic camera that looks at license plates and charges people for passing over a toll area, and it took a picture of a woman with a shirt and interpreted that as a license plate on a car, right? So that is an example of an unexpected condition, and the model didn't behave properly, right? So how these models behave under a variety of conditions is really important to think, not only during testing, but up front when you're designing the model. For years in the software industry, we've been designing systems to be reliable and safe, right? We understand that by its very nature, software has errors. But when you're talking about engineering probabilistic systems, things look very different. AI systems have errors, we know that, but we need to not just look at, how accurate these systems are and how few errors they have. In the software engineering world, we would look at that as, bug counts. But with AI, we need to take a slightly different lens and look at the kinds of errors that systems make. Okay, so the first area is privacy, or the third area is privacy and security, right? As we build these AI systems, we need to build systems that protect private information and resist attacks. I think that goes without saying. As an industry, I think we're doing okay here. We've made significant advances in privacy and security, fueled by regulations like GDPR in the US and California. We have CCPA. But with these AI systems, there's always this inherent tension between the need for more and more data. Sometimes that's more and more personal data, and this tension with the desire for privacy. And just as with the birth of connected computers, we saw a huge uptick in terms of security issues and related penetrations. We're also seeing a huge uptick in the number of security issues related to AI. And so we solve this, or we view we can solve this by ensuring that our data science processes, the process by which we do the art or the craft of data science, blends with the privacy and security practices, including the legal framework for these privacy and security practices that governs these privacy and security practices. And then the third or the fourth pillar is inclusiveness, right? There's 1 billion people around the world with disabilities. In AI, it can be a game changer. It can make computer systems more accessible to those who can't access them today. But we need to step back and make sure that when we develop AI, we're developing it in a way that benefits all. and then in a way that is accessible by all. Our vision at Microsoft is about democratizing technology, right? This is just a vision we take across all of our products, and this applies to AI as well. So I want to touch briefly on the underlying pillar or principle of transparency, and then we'll flip over to accountability, and we'll get into some fun examples. So the first core principle is transparency. When AI systems are used to inform decisions, they can have tremendous impact on people's lives. But it's really important that people understand how these decisions were made, right? And when I say that people understand how these decisions were made, it's not only the people who designed the systems, it's not only the data scientists, but it is also important that people who are the recipients or the benefits of these systems understand how those decisions were made and also how their data is used. A crucial part of transparency is what we refer to as intelligibility, or the useful explanation of the behavior of AI systems and their components. This requires that stakeholders comprehend how and why models function as they do, so that you can identify potential performance issues, safety and privacy concerns, biases, exclusionary practices, and then, as the example I gave earlier, these unintended outcomes that sometimes happen. We also believe that when you use AI systems, they need to be honest and forthcoming about when, why, and how they're being deployed. And then the last pillar that underlies this all is accountability. We believe that the system or the people who design and deploy systems have to be held accountable for how these systems operate, right? So a great example of this is facial recognition. There's a growing demand for facial recognition technology, especially from law enforcement and government agencies who see the potential for technology for use in good cases, like, for example, finding missing children. However, there's a potential downside to the use of technology like facial recognition, right? It can be used by government for surveillance purposes of specific individuals. So, you need to have regulation around things like facial recognition and guidance for how organizations use this technology in an accountable fashion. So at Microsoft, our approach to responsible AI, and this weaves through everything that we do internally, is focused on 3 different areas. We focus on innovating responsibly because we're a tech company. We focus on empowering others through AI, and then we focus on fostering positive impact. So I'm going to take a little bit of a discussion about innovating responsibly and share with you some of our practices that we use internally. And then we will also highlight work on fostering positive impact. So, we innovate responsibly through a people-centered design approach. This weaves through all of our products, including things like Office and Windows that are used by millions of people every day, and the AI services that we provide to organizations to help them transform their businesses. We are implementing company-wide governance and practices around responsible AI. And I'm going to flip you over to a few of those. So the way that we approach this internally, and I'm sharing this for the purpose of not saying that this is the only way, but showing you how important it is for organizations, academic research entities, and anybody that's using AI to think and have a structure for governance within their organization that provides a framework. So at Microsoft, we have something called the Ether Committee. It's an internal ecosystem that is responsible for supporting responsible AI from a company standpoint, right? So it is comprised of a set of senior execs, and these executives come from all different aspects of Microsoft. So these are senior execs from our engineering team, our research team, our legal team, and even our operations and sales team. And our Ether committee has formed these working groups, right? A working group on privacy and security. We have a working group that focuses, for example, on human cognition and attention. We have a working group that is looking at engineering practices for AI, and not only what we do with our own engineering work, but how we can make some of this available to others through our products. And so this framework and this Ether working groups gives us a way also to look not only at what we're doing today, but to think more broadly and look forward at ways we can change things. We also have this concept of something called the Office of Responsible AI, or ORA, right? It is a functional area within Microsoft that governs, enables, and defines our company's approach to responsible AI, right? So you can think of this as a group that is doing things like setting policy, providing a governance framework, right? Ensuring that, we do the enablement of our employees, training and things, so that they can adopt responsible AI practices. And then we take what we learn and we push that outward in terms of enablement for our customers as well. At Microsoft, this Office of Responsible AI is also on the hook for sensitive use reviews. So when my team has a project and we are doing work with health data, we go through something called a sensitive use review. And there's a team of experts who triage, manage, and deliver guidance for sensitive use cases, right? And so they look at what we're doing and they provide a perspective external to my team about what the goals are for the particular project. And then our Office of Responsible AI is also focuses outward in terms of formulating and advocating for responsible AI policies externally. So that's a little bit about the ways that we structure our thought work internally from an organizational perspective. I call this out because I work with over 200 different, what we call grantees, so people who have artificial intelligence projects. I don't see this, to be frank, in all of the organizations that we work with, right? We work with a lot of people who want to do artificial intelligence, but sometimes they haven't taken these concepts and really internalized them from a structural standpoint inside their organization. So I wanted to offer that if you're not doing that already today within your universities or institutions or entities, you should perhaps consider something like that. Okay, so I also want to look at the second pillar of empowering others. So we believe in helping organizations cultivate a responsible AI culture, right, through their own business practices, putting whatever their own principles are in place in some of the ways that I spoke about, right? And this leads from implementation to governance. This is all about providing practical tools and guidance. These resources are meant to empower people at all levels. By example, our AI business school is really targeted towards business leaders who want to develop their own strategy. So, who want to learn and grow a strategy that's right for their own company around responsible AI. And then the third scenario is about fostering positive impact. And this is where the work that my team does from an AI for good perspective starts to ladder up. So let me take a pause here and flip over to a discussion around AI for good. So at Microsoft, AI for Good is really about helping or empowering people to solve some of the biggest challenges out there today. It's a $175 million initiative to empower researchers, nonprofits, and organizations with these advanced technologies, including artificial intelligence, to help unlock solutions to some of these big challenges. The work is focused in 5 different areas. It focuses on accessibility, there's a focus on Earth, there's a focus on humanitarian actions and crisis response, there's a focus on cultural heritage, and there's also a focus on health. The work that my team does ladders up to this interest in health. So my program is a $60 million 5-year philanthropic program. We're geared at empowering those who are working on the front lines of health to tackle some of the challenges in health. We have the same collaboration model that you see kind of filtering across all of the AI for Good pillars, and that we work with predominantly nonprofits and academic research entities. And we do this in a couple of different ways. We provide access to AI and technology through grants. And we also provide access to AI and technical experts through what we call in-kind collaborations, so collaborative engagements with grantees. The work that we do in the context of the collaboration is based on this, foundation of responsible AI. So privacy, security, and ethics that I alluded to in the prior conversations. We've developed a framework that takes these responsible AI principles and manifests them in the terms of all of the work we do in collaboration with our grantees. A note about what we're doing. It is an open source program. We believe in open research, right? So when we work in collaboration with grantees on these artificial intelligence projects, we don't retain the IP. The data science solutions are shared with the world. They're made open through open source. And the goal here is to enable the research community to take these artifacts and accelerate it, to adopt and accelerate and drive broader impact to the world. So this is just a little bit about the framework that we have in place for the grantees. We take a portfolio-based approach on our health work. There's a lot of problems that you can solve with technology. There's probably a lot of problems you can't solve with technology. But stepping back and looking at the space of health is huge. And so we try to narrow this by taking a focus area. And what this does is it allows us to not only grow our own internal expertise in these areas, but it enables us to partner with experts that align with this portfolio. We have over 200 projects that cross these 3 pillars or areas. I would say roughly 2/3 of those projects are in this Quest for Discovery bucket. The Quest for Discovery bucket is really, think of it as basic scientific research, right? Accelerating this medical research so you can advance the prevention, diagnosis, and treatment of disease. We also do, I would say, roughly around 50% of our work, maybe a little more during COVID, is really in this area of global health insights. It's increasing our shared understanding of mortality and longevity and looking at this as a way to protect against global health crises. So we did a lot of work in COVID-19 in this area. I would think that this almost as population level analytics, rich visualization, and modeling. And then the third area is health equity. So improving access to care for underserved populations. And this includes not only people who are underserved from a healthcare delivery perspective, but also vulnerable populations. This vulnerable populations could be people who are vulnerable based on income level, or populations who are vulnerable based on race and ethnicity, or vulnerable because of needs for accessibility. So health equity, again, is our third pillar of work. So I'm going to just share with you a few partners and grantees that you work with, and talk through in this context a little bit of some of the challenges. I want to highlight our work with the Novartis Foundation. So this work ladders up to the health equity pillar of our program. A little bit about leprosy, because I think it helps you understand and set the framework for why artificial intelligence can be a game changer here. Leprosy is one of the oldest diseases in the world, right? I mean, it's from biblical times. You've seen references in some of the historical literature. But there's still an estimated 2 to 3 million people in the world today living with leprosy. And I would say many people in developed countries are not aware of that, right? They think it's a solved problem. And every year there's over 200 new cases of leprosy. And the sad part about this is that we know that early detection can help, right? It can radically change the course of the disease and prevent some of the disfiguration that's typically associated with leprosy. But the challenge with leprosy, and this is where we get into the area of health equity, the challenge is that there's such a great stigma associated with it. Historically, a huge stigma associated with it, right? People with leprosy were, sectioned off and cordoned off in leper colonies, right? So even today, this permeates cultures where leprosy is a problem. So the goal with the Novartis Foundation here is to use artificial intelligence to create a simple mobile app that enables a quick, accurate, and secure remote screening for leprosy. The focus here is that very often individuals with leprosy live in hard to reach areas, right, where there's limited access to quality health care. Right. And very often the healthcare resources in these areas aren't properly trained to be able to do the diagnosis and detection through an exam. So you need a tool for self-screening. The tool for self-screening also helps the individual do this in a private way, right? So they can kind of get an indicator, do I need to go seek care? The screening app connects to the cloud, which is used to not only capture images of lesions on the body, but also basic biomedical information or phenotype. The images are securely uploaded to the cloud where trained AI models scan these lesions and classify the lesions with speed and accuracy. And then there's a real-time recommendation made, a prediction that is shared, and that an individual can then use to determine, should I go to a clinic, right? Should I travel to a clinic and seek out a clinician who can do a definitive diagnosis, for example, with a skin slit smear? The outcome of this, Novartis Foundation is a founding member of the Global Partnership for Zero Leprosy. And this Global Partnership for Zero Leprosy has a goal to not only accelerate early detection, reduce stigma, but ultimately they want to eliminate leprosy. And so Novartis Foundation is taking the model that we built for leprosy, and they're going to turn it over to the Global Partnership for Zero Leprosy. And they will make the imagery database and the AI code publicly available to enable other researchers. So that's an example of artificial intelligence in health. Some interesting things from a responsible AI standpoint. So this is definitely a project that we internally took through a sensitive use review. When you're taking pictures of the lesions, some are of just lesions themselves, but others, there's a set of images that are of large body areas. And the large body areas sometimes have identifying marks. These could be things like, very distinctive tattoos or very distinctive scars, or in other physical manifestations that could potentially be used to identify somebody. And so this is an example of where our project lead took this through a sensitive use review as a part of the process. I want to share a little bit about the work that we're doing from a consortium standpoint. A lot of research happening in artificial intelligence, and in many cases, you're starting to see academic entities come together, coupled with commercial entities and philanthropic entities all together in consortiums. An example of this is the Cascadia Data Alliance. This is really a group of academic entities and commercial entities that are focused on accelerating cancer research collaboration across borders. The initiative is really aimed to look at data sharing and then collaborative research using artificial intelligence. So from a Microsoft perspective, we're working closely with our colleagues at the Fred Hutchinson Cancer Research Center, University of British Columbia, the British Columbia Cancer Agency, also known as BC Cancer Agency. And we have a number of projects through the Cascadia Data Alliance where we're looking at things like acute myeloid leukemia, breast cancer, prostate cancer, and imaging data. We also have work through the Cascadia Data Alliance that is looking at differential privacy and other techniques to enable secure private sharing of data. We have worked with UBC in particular on the use of synthetic data generation using something called GANs, or generative adversarial networks. So again, the focus here is that this trend that you're starting to see, not only with the Cascadia Data Alliance, I mentioned earlier the HPC Consortium for COVID-19, but you're starting to see these different entities come together and couple technology expertise with domain-specific expertise. And then I want to do one call out in particular to COVID-19, because I really think that some of the challenges that the world faced over the past 2 years have accelerated the use not only of high-performance computing, but also artificial intelligence. So my team works specifically with UCB, a global biopharmaceutical company in Belgium. The COVID-19 Moonshot was a UCB employee-driven effort to accelerate the research for a potential cure for COVID-19. So UCB was not engaging as a company in the design and research for therapeutics, but they had a number of employees, just like we did at Microsoft, and I'm sure you did at your own institutions, who are passionate about taking their talent and their skills and their time to try to help with the COVID-19 project, thus their engagement in the COVID-19 Moonshot. And so this is an example of, where you're leveraging the massive compute power of the cloud, right, with data, and using this and models to be able to screen chemical targets and potential chemical entities for research. So the Moonshot identified 150 new molecules that could potentially counteract replication of the SARS-CoV-2 virus. And this information has been used to aid in drug therapies. These candidate molecules have all been made available broadly through the open nature of the COVID-19 Moonshot project. And again, that goes back to the pillar of open AI and open research. I do want to give a call out to another set of information and project around COVID-19, and there's a particular reason for this. Sometimes when we look at artificial intelligence, we think of it only in terms of machine learning and deep learning. And I would offer that we should open our aperture a little bit and also think not only about responsible use of data for artificial intelligence, but just more broadly responsible use of data, right? And one of the sets of work that we did for COVID-19 was work with Brown and Harvard University to build interactive maps built on Microsoft Power BI to be able, so people, including laymen and policymakers as well, so they could understand risk level according to geographic location. And so again, the thought here is that it's not just about machine learning, deep learning, NLP. Open the aperture a bit. I like to see when we think about just traditional analytics and visualization of data, that we're also taking these responsible AI principles and applying them to these types of projects. Oops. So with that, I want to say thank you for inviting me today to share some of the thoughts around how Microsoft looks at responsible AI, the way that we structured our organization and our practices and our policies to support what, our philosophy around responsible use of this technology. We're not the only company doing this. There are many people out there. I love the fact that groups like this come together to share best practices, because through this all, I think we learn and hopefully can use these technologies in a responsible way to advance areas that will support, important things like health and human longevity. So with that, I'd like to thank you.